If you are a heavy user of ChatGPT, you may see the many limitations of AI products today: hallucinations, out-of-date information, lack of domain knowledge, or the need to process confidential data. This leads to a solution called Retrieval Augmented Generation, which is drawing more and more attention in Silicon Valley. In this video, I'm gonna introduce what RAG is and what researchers and startup founders say about its future. Okay, let's take a closer look at the limitations I just mentioned. All of these indicate the need to incorporate additional information into a product built on top of a pre-trained large language model. The RAG paper was first introduced by Facebook AI Research in October 2020, aiming to improve performance on natural language processing tasks. Let's have a minimal working example. Suppose you have a list of tourist recommendations that you want a large language model to be able to talk about. Here, we view each line as a text document. When a user inputs into the system, "I like to hike," the system can search through the list and retrieve the most relative document, which we define as the line that has the most identical words. The relevant document retrieved is "Go for a hike and admire the natural scenery." Then we propose a text prompt by filling the part for user input. Now the system can take the new prompt to the LLM, which will return some kind of response. Bam! You get the fundamental idea of RAG. This is the most simplified version and, in reality, has a few potential improvements. We could store these documents in a vector store depending on the needs for scalability, cloud support, and multimodal support, and pre-process the documents and user input to encode them in a word vector space where each word is a vector in high-dimensional space. And we can switch our similarity measures for the vectors accordingly. Dot product of the two vectors, cosine similarity, which measures the angle between two vectors, Euclidean distance, which measures the distance between the objects being searched. There are also advanced RAGs with more modules and different components. RAG has gained wide attention since the summer of 2023. We see big tech companies have started providing tools to help their clients build RAG applications. For example, Google, Amazon, IBM, Microsoft, NVIDIA, and so on. Kerry Brisky, the vice president of AI software at NVIDIA, says, "Expect to hear a lot more about RAG as enterprises embrace these AI frameworks in 2024. Let us imagine using RAG in these real-world scenarios, some of which are already a reality. Educational tools. Education platforms use RAG to generate study materials and create detailed explanations of complex subjects. Customized chatbots. RAG-powered chatbots and virtual assistants provide more accurate and contextually appropriate responses to user queries. Interactive entertaining and gaming. RAG is used to generate dynamic narratives, dialogues, and storylines based on player choices and actions." Many of you may wonder when to use RAG and what's their best use case. A 2024 article concludes that RAG best fits a high external knowledge and low model adaptation scenario. Seva Sarandira, the CEO of Laser AI, states that RAG suits long-term production apps, while large prompts can be used in one-off scenarios. Richard Zhang, CSO of C Studio based in Shenzhen, China, points out the three common ways to personalize large models' outputs: prompt engineering, RAG, and fine-tuning. RAG is the best solution for adding domain-specific knowledge to LLM, whereas fine-tuning is good for complex prompts or special output tones. In some cases, a hybrid mode is preferred. Many startups have adopted RAG in their AI products, and some others decided not to. Let's hear their experiences. Srijan Kumar, professor at Georgia Tech and the founder of Lighthouse AI, shares that RAG reduces but does not solve hallucinations. In a finance assistant use case, my startup showed that a RAG system gives correct and complete responses only 57% time, even to simple queries. Richard in response, emphasizes that RAG is still the most effective way to reduce hallucinations. He shares with me that improving the satisfaction rate from 60% to, say, 90% goes beyond the technology itself. A team needs to have a good understanding of the business logic and clean the data properly before optimizing RAG. It's a challenging long-term process. Lucky Zhang, the founder of Sakai, just launched a mobile app that enables users to create and explore personalized what-if stories with AI characters, fostering a global storytelling community. He shared with me that their product didn't adopt RAG because the context window length has been enough to use, with an estimate of 10,000 tokens per conversation. A hotly debated topic these days is whether RAG will become obsolete due to longer context windows. Due to memory and computing power limitations, large language models can only memorize recent user input, whose length is called context window length. LLM's context window lengths have grown longer and longer. Following Google's Gemini 1.5 release with a context window length of 100K tokens, many folks shout out that RAG will be dead because additional information to LLMs can now be part of the input prompt. Many well-respected members of the research community expressed disagreement. Aurel Vanels, Gemini's co-lead at Google DeepMind, says RAG has some nice properties that can enhance and be enhanced by long context, which reflects his belief that RAG and long context will complement each other in the future. Saiva Sarandira emphasizes that RAG is cheaper and faster. Yao Fu, a CS PhD at the University of Edinburgh, defends the potential of long context models over RAG by arguing that despite higher costs and current limitations, long context models offer superior on-the-fly retrieval and reasoning capabilities. The possibility of language models accessing vast databases directly, like Google's Index, might be a future advancement. Jin Fan, research manager at NVIDIA, envisions some hybrid method that combines retrieval with a long context window, perhaps some form of spreading neural activations across a giant unstructured database. Elvis Aravia, the founder of Dare AI, also acknowledges the effectiveness of combining RAG and long context LLMs for a robust system. He states that different families of LLMs will help solve different types of problems. We need to move on from this idea that there will be one LLM that will rule all. James Nguyen, a senior principal cloud solution architect at Microsoft, mentions a few of RAG's long-term limitations in his article. For example, the processes of retrieval, augmentation, and generation are handled independently. This means that the LLM for retrieval might not understand the user in the same way as the LLM for generation. If the retrieval phase yields irrelevant results due to poorly chosen search queries, it may end up making up a response, aka hallucination, again. Alternatively, he proposed to develop an intelligent agent. Ethan He, an AI researcher from NVIDIA, made a ActGPT with sort of similar idea a year ago, where an agent retrieves up-to-date information from Google and performs tasks like writing a marketing post on Twitter. As a contributor to the project, I, Cindy, think it mitigates hallucination and data freshness problems, but cannot, say, process confidential data. What alternative solutions will thrive? Ethan wants to explore more about the mixture of experts, or MOE, which is an architecture that combines multiple LLM modules for a gated result. To sum up, it seems from research outcomes and startup practices that RAG is still the most effective way so far and will not be replaced in the next 5 years. In the long term, smarter architectures may evolve and eventually outperform RAG. We'll see. Thank you for watching.